Hello, and welcome to the tutorial on mobile testing on built-in calculator app using a real device. So as we can see here, this is the UI of the built-in calculator app of the Android mobile phone. And the objective of today's tutorial is to test the calculator's functionality for the basic arithmetic operations like addition, subtraction, multiplication, and division. And also, later on, we will verify that the displayed results are accurate for the inputs. Moving on. So before we start on with the tutorial, there are some prerequisites that needs to be considered. First of all, the Java Development Kit or JDK needs to be installed on the computer that we're working on, as well as the Node.js and the latest version of Appium, and also the Appium Inspector software. The Java Home and Android Home needs to be set in the environment variable path, and also the device you're using needs to turn on the developer mode with enabling necessary permissions for downloading via USB. And also for testing purposes, we need to install a testing framework. We're using TestNG here. In the IDE of your preference, I'm using Eclipse IDE here. And the installation of these prerequisites are available on the internet. So please make sure that these prerequisites are satisfied before we carry on with the tutorial. Okay, now that the prerequisites are completed, let's carry on with the tutorial. So first of all, your device needs to be connected to your computer using a USB cable. And to check whether the device is correctly connected, we need to run the command adb devices, which refers to Android Debug Bridge. So here we can see that in the Visor software, this is the real-time footage of my connected mobile phone. And in the CMD, if we run the command adb devices, we will see the name of this device. And also, if we want a more descripted detail of this device, we can run this command and we will see also the model and the transport ID of this device. Now that we have securely connected the device, let's move on with locating the app package and app activity. So we need to locate the app package and app activity of the built-in calculator app. So to do that, let's first of all open the calculator app in our phone. Okay, now that it has been opened, let's run this command. First of all, adb shell. We can see that the shell has been activated. And now let's put it side by side so that it's easier to understand. We will run this command. So dump sys. Okay. Okay, so we have got this line which tells us the app package and the app activity of the app that is currently on focus. And the focused app is the calculator app. So now that we've gotten the app package and app activity, let's get the Android version. So to get the Android version, so we can see that we have the Android 10 application. Now that we have accumulated our needed information, we can carry on with the process. Let's open a new command shell and run appium allow course. So we're activating appium here and we're also allowing course. We're doing that because we have connected a remote device using USB. If we would have used an emulator that is in the same host device, it was okay without using the course. But as we're using a remote device here, we have to allow the course. So by entering, we can see that the Appium has been activated. Great. Now that it has been activated, we can open the Appium Inspector app. Let's minimize this. Okay. So in the Appium Inspector app, first of all, we have to write the remote host and remote port. So as we can see that this here says the remote host, and this is the remote port. And we can see that the same remote host and port is being used here. So we won't need to change these. What we need to change is the JSON representation here. But first of all, let's see what happens if we want to start the session. Okay, we have got an error that the capabilities found are undefined. So we haven't really identified the capabilities. So we need to identify them. So I have read a JSON here. So I just need to copy this. So let's edit this here. So to get the automation name, we have to run a command Appium, Appium driver list. So we can see that the installed Appium driver is UI Automator 2. So we're going to use that. And now we have to fill up the value of platform name, platform version, device name, app package, and app activity from the values that we have obtained from the command prompt. And then we need to start the session. Okay, so here we can see three sections. Here is the UI of my calculator app. So this is the app source where we can see the XML codes of this UI. And this is a very important section. So if we select here, we will see that the item that I have selected here has been described here. So we can find the attributes and the value of this element as well as what attributes we can find it by and the selectors. If I want to select 8, we can see that the selected element, we can see that the ID of this button that contains the number 8 is this. So we can find it by ID, Android UI Automator, and also the XPath. It is best practice to find it with ID, but if ID is not available, you can do it with the others that are available at that moment. There arises a question that why we actually are using the Appium inspector. So if we want to automate the calculation here, for example, I'm using an arithmetic operation of 8 plus 6. So let's see what happens. So here we can see 14. So we know that 8 plus 6 is 14. So that means that the calculator is giving the correct answer. But how can we automate this test? That's the question. So if we want to automate it, we have to write a testing code. And for that, we need to uniquely identify each of this element so that we can run the test. And for that, we need the Appium inspector. And each of this element have their own unique accessibility ID or ID that we can find it by. And we can use these attributes to perform the arithmetic operations. So now that we are familiarized with the Appium inspector, let's go on with the testing codes. So now we'll create a new Maven project. So to do that, we'll use a simple Maven project. And by clicking finish, Eclipse will create a package for us. And in this architecture, first of all, what we need to do is go to the pom.xml file. And to run the test, we need to install the dependencies. We need two dependencies here. First is testng and second is Appium. To import the dependencies, in your browser, go to the Maven repository and from there, import the dependencies of testng and Appium. Now in the main/test/java, create a package and under that create a test class. Now come in the Appium inspector and we can see in the source information there is a sample code given for JUnit and we need to customize this code according to the technologies that we have used here. We have customized the code by using methods for testng instead of JUnit and also use the Android driver as driver. And in the driver option, we notice that the options amend the given specification of the mobile device and the calculator application. Now let's write the test cases for addition operation. For example, if we want to add 8 to 2, first we need to click 8, then we need to click the plus sign, and then we need to click 2. And last of all, we need to click the equal sign. After we get the result, we need to verify whether it's 10 or not. To click the number 8, we first need to find the element by its ID. To get that, we need to go to the Appium inspector software. Then we write in the code driver.findElement, then appium by method.id, then we give the ID of the 8 and then dot click. Then we write code the same way as we have done for each of the test cases. Now we need to take note of the value in the result section as well as the result format. We'll get the text of the result section and store it into a string called result. If we pay attention, we can see that the result format is equals space then result. So when we are to compare the result, we have to take into consideration this specific format. If the result matches the desired string, then the test cases for the addition operation passes, and if it doesn't, it fails. Now let's run the test as run as testng test. As we can see in the console, the test failed as an element could not be located on the page. Now let's see why that happened. Let's restart the Appium inspector session. We can see at the initiation, the whole screen is treated as a single component because of the tap here to minimize message, and we can't select any digit separately. To do that, we need to first click on the screen at random, and then the digit pad is activated. So first, we need to identify the initial screen component, and then we can conduct the later test cases. And this time, we can see that the test runs successfully and gives the correct output. Let me fix the comments so it's easier to understand. Another thing to consider is that we cleared the result section before conducting another operation. We do that by clicking the AC or C button. Now that we have successfully run the test case for the addition operation, we need to do the same for the rest of the three arithmetic operation. One thing to take note is the accessibility ID for the operation buttons are different. For subtraction, it's subtract, for multiplication, it's multiply, and for division, it's divide. For 8 minus 2, the result will be 6. For 8 into 2, the result will be 16, and the result of 8 divided by 2 is 4. Now let's run the program to test all the test cases of the 4 arithmetic operation. Now that our testing is over, that wraps up our test execution. As we see, all the arithmetic operations like addition, subtraction, multiplication, and division pass successfully, validating our automation setup. This demonstrates the power of Appium for mobile testing, enabling us to interact with a real device application, and the utility for TestNG for structuring and managing our test cases. Tools like Appium Inspector played a crucial role in locating UI elements efficiently, as we have seen, simplifying the test development process. That was it for today's tutorial. Thank you for watching.